Hey guys, how's it going? On today's video, I am going to be showcasing basically how to create your own link processing pipeline. So if you've worked with LINQ before, then you know you can write these complex LINQ queries that can do all kinds of cool things. And there's all kinds of providers out there that can allow you to connect to databases, allow you to connect to document databases over HTTP and many things. So in this video, I'm actually going to show you how they do that and what the components of creating one is. And we're actually going to walk through creating one over the course of the video. So to get started, there's really three key parts of a LINQ query. In terms of like processing it, there's three things that you're going to have to create. You're going to have to extend some kind of iQueryable. And the purpose of the iQueryable is that it really provides a trigger point for connecting into the provider. I mean, it's actually also that trigger point is what actually executes the fetching. And ultimately you receive the expression associated with the link statement that you've written. And then you can then pass that on to the query provider, which ultimately passes it on to the expression visitor. The query provider essentially is what triggers the visitor. So you're gonna, once you have the expression, you're gonna use an expression visitor to visit that expression. And ultimately, an expression is broken out. It looks like a tree. So you're walking that tree and just picking what you want. And the expression visitor itself is what you typically use to gather what the intent is. So basically pull all the structures together into some format that makes sense to you. And then you can then back in the query provider basically take that process intent and actually do something, do the thing that LINQ query is trying to do. Then once you do the thing and get the results back, then it's now the job of the query provider to then take those results and return them back to the queryable, which ultimately returns them back to the source. So what does that ultimately look like? So what we're going to do in this video is we're going to actually try to emulate this capability as you see it here using our own custom queryable, not the built-in list. So from our example, we know that the first thing we need to do is we need to create something to extend iQueryable. So I'm going to create something called a folder, and I'm going to make it a folder of T, because again, remember that we want to make it more robust than the example we have here where we're just using a string. We want to be able to actually iterate through essentially anything, right? Any kind of type. Now I'm making it somewhat generic here, but of course this is still going to be scoped primarily to a folder. But I can create our own iQueryable, which of course will take the T, and I also will need an iOrdered queryable. Okay, and with this done, the next step is basically to implement the interfaces, and that'll give you a basic template for the things that you need to have as part of this resource. So let's fill some of these in. For element type, we know we're only going to be using files. So I'm actually going to change this to the type of file info. For the expression, I'm going to create an expression. So the next thing we need is we also need the query provider, and I'm actually going to just quickly create I'm doing it now so that I have access to the actual class so that I can use it and reference it in my code. So I need a folder query provider. And then of course, what I'm going to need is I'm going to need the actual folder that's going to be the folder that I'm querying. So and I'm just going to set that to not null. And now, having created this folder, let's create a closed version of it that basically inherits from a folder that takes the file system info. This is so we don't have to keep passing in file system info when we actually create it. And now let's go over here and let's create our first constructor. Okay, and we know that root path is equal to root path. And so we can actually do the same thing here. And now that we have all this, let's see how far we've actually gone. So old way, and I'm gonna go over here and say new way. And in here, I'm actually going to do, and in here, I will actually put the same directory. And I'll actually comment this out so that we don't have to see that right now. So looking at this, the first thing you'll notice is that obviously, because it's an iQueryable, this code now compiles, right? And it's working just fine. But what actually happens in there, right? So let's see. And I'm gonna put some breakpoints in here so we can actually go through it. So if I run this, you'll notice that nothing actually happens other than the constructor starting. So here's the constructor, it goes in here, comes out. And now it's saying method not implemented. What method is not being implemented? Well, the method that's not being implemented is this folder dot expression. So it's expecting an expression to be there, right? So that's the expression, as you saw, that we already provided. So one interesting thing about using this is that there's a bunch of mechanics happening in the framework that's calling into your code, and you have to supply the appropriate parameters for everything to work properly. There's a couple more things that we have to worry about, but let's just run this again and see what happens now. So what we see here when we run this is that the expression is still getting this object reference not set to an instance of an object, right? And it's not clear to us what is causing this issue, but we can make it a little bit clear by converting these back into their regular format. And over here, I'll use the Visual Studio's new approach to it, or new features which allow you to convert back and forth between the two. So you now end up here. So I'm going to put my breakpoints into these properties. All right, so now when I go through, you see it goes into provider, and provider is showing as null, and that's returning. And it's going to expression. Expression is showing as null, right? And so because those two things are null, something that's happening within the runtime is causing failure, right? And you can see the call stack is not necessarily even providing a lot of details other than that this is null. So where do we get that data from? How do we populate this, given that it's going to basically fail at this point in time? Well, in the constructor, we can actually provide what these values are. So what I'm going to do here is that because I don't know what t is, I'm actually just going to create an enumerable of t, any enumerable of t. And then I'm going to use that enumerable to basically get the expression. So that now gives us the expression. So our issue is now the query provider. So for the query provider, we have a query provider. So we simply have to specify that query provider. But first, we obviously need a constructor. Okay. And so over here, we can basically instantiate a new query provider. And we're basically going to pass in the root path. All right, so we now have the query provider and the root path set up. So we now know that this is going to run properly because we have the actual objects. Here's a query provider being returned. Here's the expression being returned. Again, remember there's a lot of exceptions inside the query provider. So create query is being called here. And as you might imagine, this says not implemented. So we're going to actually implement it right now so that this actually passes through. So what the query provider or what the framework is looking for here is for us to tell it what the queryable that we plan to use is. Okay, and this should work. The only real problem here, I'm going to remove that, is that basically we need to instantiate this folder, right? So we can instantiate it. We have the folder information. So let's pass that folder information in here. So because we've created the new one here, this new one doesn't have the expression and queryable associated with it, right? So we have to populate it. So we can actually go up here and we can create a new query provider and a new expression, which we then, of course, save to local state. And then we should probably also pass in the root path. And then, of course, we need to go in here and make sure we're calling the appropriate version of the constructor. And also make sure that that same version is expressed up here. So with this starting to get a little bit bigger, I'm going to actually move these using a cool new Visual Studio feature into their own file. I'll create a nice little folder for it. So when I run this now, I should make it through to the end with no issues. And as you can see, this is returning me a folder, which is a queryable that I can then execute on. All right, so we got this all set up. And as you can see right now, our items returns a file system info, which if you go here is basically what we're using. We're not using this version of folder, which basically you can specify any type in there. We're actually using a version of folder that concretely wraps file system infos. So as you know, when you run a LINQ query, your iQueryable is what's sitting at the top of that query, and nothing happens until you actually request information. So as of right now, once we get to this point, nothing is happening. We've just returned a folder, which is just a queryable. Once we make this initial call, it's actually going to go into the queryable and start fetching the data as it's needed. And it does that by that initial call for get enumerator. And as you know, that's basically not implemented right now. So when I click in here, I'm going to get the exception telling me, hey, nothing is implemented. You got to give me that enumerator. Now, before we can get going with that, there's one more type that we need to add, and that is the expression visitor, right? So if you recall, the last piece is that you need an expression visitor, which you're actually going to use to process through all the nodes of the expression that have been created by the query that you've written. So for example, this equates to some kind of an expression, and you now need something that can loop through it, parse it, iterate through it, and process what you're trying to say. And for that, we're going to create a new type. And of course, this will take the root path, right? Because we need to know where to go for it. Okay. And we're also going to move this out into its own class. And now going in here, we know that there's going to be different types that get returned by this query that you're writing. Because right now we're looking at file, which would obviously return file infos. But what if I just wanted the name, right? If I want the name, then although this is still a folder queryable, notice that now this has now changed to returning a queryable of strings. So based on the type, this changes. So that we can push all the way down into the visitor itself, and we can say that we want the type exposed here. So the next thing that we're going to do is we're actually going to create an evaluate method. And this evaluate method is just a method that I'm creating. There's all kinds of methods that are built into Expression Visitor, but we want to have a method that we're going to use to basically compose everything and execute it at the visitor level. There are multiple levels where you can do your processing, and it's going to make sense to you as you're programming the right place to put it. In the future example, I'll show you putting it somewhere else. For this example, we're actually going to put it inside of evaluate. So the first thing we're going to do is going to do a visit. After the visit is done, we're going to loop through. The results are visible. We're storing a local variable, and then we'll return that local variable. So let's create our local variable. Ret equals new list. It's going to be an equal to a new list of t. Right, that's the t that's been passed in there, and we are returning. So that gets that done. So now we're going to jump back to the query provider. I'm just going to create a function, and this of course returns t results. We're going to specify that type in the function. Let's call it sample execute. This is our custom execute. Let's call it custom execute. You can call it whatever you want, of course. And this will take a t as well as a t result, and we'll tell you what t is for in a second, and we pass in an expression in there. Okay. And right now it throws not implemented. So where does this come in? So this comes in back at the folder when we get the enumerator. When we get the enumerator, we are actually going to simply return the query provider we've created. We're going to return the custom execute, and we'll pass in this t that's specified here, as well as an IEnumerable of t, which is what t result ultimately is. And it's taking the expression, and then it's getting the enumerator for it. All right, let's just parse through that. So what is t here? T is whatever you pass in here. T is whatever file selects. So when it's just file, then t is a file info. When it's name, then t is a string, right? Depending on what you do here, t is going to change. And what is the IEnumerable of t? The IEnumerable of t is the enumerator that's going to be used to loop through this loop one by one. So if it's a string, then the IEnumerable is going to be a string and going to get strings. If it's file info, then the IEnumerable is going to be of file info, and you'll get file infos. And then what is it doing? It's passing these things into this custom execute, which we pass our expression into, the expression that we created earlier. And then we're just getting the enumerator for that, so that it's going to loop through and return that t each time, whatever that t is. So that's pretty much it for what needs to happen inside of the folder itself. It's pretty much all set. When it gets past here and you get to here and it makes the first call to get enumerator, it's going to go in here and it's going to make this call to custom execute. So let's go into custom execute. That's over here. And then the question is, what does custom execute need to have? The custom execute, all it really needs to do is take this expression. There's a lot of things it can do, but amongst all those things, ultimately, we need a way to convert this expression into this IEnumerable. But in order to get an enumerator for it, I need to know what it is. What does this expression mean? Number one. And then number two, so what is expression? And then number two is get the data from executing the expression. And then finally convert the data to IEnumerate of T. So how do you figure out what the expression is or do all those things? Well, in this case, we're going to use what we just created, which is the folder query expression visitor. And what are we going to pass in there? We're not going to pass in T result, but because T result is the whole entire enumerator. We just want to know what T is from T result. So we're going to pass in T, and this of course takes the root path or folder. And then get the data from the executing the expression. So that's the next step, which is that we are now going to then do visitor.visit. Okay. And that would be the normal way of doing it. But if you recall, in our code, we created something called a method called evaluate. So instead of calling visit, in this case, we're going to call evaluate. So what evaluate is going to do is it's going to actually do that thing, get the data from executing the expression. So you see evaluate actually takes the expression and it returns an IEnumerable of T, which is what we want. And then our final step, since we know that T result is actually an IEnumerable of T, we can essentially just return T result after converting it. So again, that's it for this. All we've really done is taken that call when they call get enumerator, that then calls this, and this then creates a folder query expression visitor, passing that same folder, and then does the evaluation. So we're just pushing it on to the next place to do the evaluation. And this class is essentially done. These will not be called. Now in a very, very sophisticated implementation, these will obviously be used in various scenarios, but for what we're doing, these are not called. So the final step is now to go into the visitor itself. And let's look at how the visitor works. So the visitor works by basically going through a tree node, like any tree, and essentially for any node in that tree, for any branch of that tree, you can write a visit method call or visit something, visit X, right? And it will call your function. It'll override that version of it. So if, for example, if I do visit, you can see that you have all these visit binary, visit block, visit catch block, visit conditional, visit constant. There's tons and tons of them, right? These represent whatever is inside of your expression. These represent the actual code that you see here. So if I had a where statement in there with some conditionals, then you would have a visit expression or whatever it is that would basically return you back that structure so that you can evaluate however you want to evaluate. So what you have here is functioning the same as what was previously created. You can see that you have the 5 things, A1, A2, and nothing else is showing. Basically, this code up here and this code right here are the same thing. You can even add your skips and your takes to it, and you'll get the same result. Now, what you'll notice is that from the perspective of LINQ, it's made to look very much like SQL, like a normal SQL query. But underneath that, you can see that there's actual method calls being called. There's a select method call, the order by method call, the where method call, and those are actual method calls that are being run on this array that we're working with, which is the array of all the files in sample folder. Well, with that understanding, when we go into the visitors, we know that we want to be visiting method calls, because it is method calls that represent the LINQ queries themselves. So what I can do is I can override visit method. And then when you use a visit, you'll get a method call node that represents the actual structure of that method call that you're exploring, right? And I'm going to take a pause there, and we're going to just walk through this one time before we go into actually processing the various statements. Okay, so we're right here, and we're doing the select statement, which is not going to do anything, and we're now in the for each. So when I click in, as you can see, it's going to go into my get enumerator. And when I click in there, you can see it goes into the custom execute, which then creates the folder query expression visitor. And then when I obviously click in here, it's going to go into the evaluate, which is where I'm at, which then brings me into this visit method call. And we can see the method call expression, which is a node. And if I open this guy up, I can see that there's a method property on it, and that method property has, among other things, a name, and in this case you're seeing that it's saying select. So you do have some things exposed to you that you can use to indicate whether or not you're executing one thing or executing another. For now, I'm going to remove that, and we're going to go back here. All right, so what I've done now is I've simply created some code in here for the various instances that we're worried about: the where clause, the select clause, order by, and order by descending. And while I'm at it, I'm gonna also add another method, which basically does a visit constant. And in here, I'm gonna do a little bit of cheating. I'm going to actually simply create a new directory info object, passing in my root path. And then let's go ahead and let's actually add items. And what I'm going to do in here is I'm going to basically, so all I'm doing in here now is that when a constant is visited, I'm basically using the root path to pull out all the directories associated with it and all the files associated with it, and then just storing it in this items. So going back here quickly, I could then, go through and essentially add each one. So essentially, I'm casting it to T, right? Again, these are all objects, whatever they are, I'm going to cast them to T and essentially return it. So this method is essentially done. Okay, so I did make one mistake here that I need to correct. This is actually not add, but add range. So we now have our environment basically set up. So let's go ahead and let's run this, and let's see what is inside of this select method call. So basically, when the select is called, we know the method, so we've used that already, and there's two arguments here. The first argument is for a generic list of file system info, and the second argument is just telling you how to express the lambda. So what we can do here is we can actually identify this first item as a constant, and then we can visit that constant. And then once that's completed, we can then look at the second item, which is a lambda expression. So we extract the lambda expression out of it, and all we're doing is just converting it into a lambda expression. And then what we can then do is we can actually do a little bit of cheating, because at this point, after we call this, we know that items is going to have everything inside of it, right? So all the 8 things that we looked at, we understand that. So we can actually use this lambda expression, and we can actually execute it against each one of those items. In the case of select, what is the lambda expression? The lambda expression is just, hey, return me file, okay? So what we're gonna do here is we're essentially just going to do items is equal to select, and then I, and then we can then do the lambda. We're going to compile it, and then we're going to dynamically invoke it passing in I. And then we return the list for that. Okay. And I don't really think I like this, so I'm going to actually take this out, and I'm going to say, all right, I don't want to compile it each time, and then I can just do compile lambda.dynamic invoke. There we go. So with that done now, when I run through this, it should pass all the way in here and pass into select, and we can go in here and we run the compile query, and then after running it, we basically select against it, and then that just returns my list of items, and that rolls all the way out through here. Then I can loop through here and convert each one into type T, which is of type file info, and that gets returned here. And now what I have is an IEnumerable of file infos that I can then just cast to what they are, and then that returns from the get enumerator call. And then when I get in here, I am now looking at a file info. Okay. All right, so let's now comment these out, and we will now run this. And what we should end up with is something like this, which is essentially what it was before. But there's a caveat now, because over here, I can now say name. So now with the name set, let's run this. And the first thing you're gonna notice is that this is actually going to break once we get in there. Now, why is it breaking? Right, so again, remember that we're dealing with types here, and when the type is known and predictable, everything works appropriately. So for example, if I'm just doing file info, because I've specified folder, if I'm just doing file info, it all works like a charm. I'm in here. But the moment that I change it to, for example, returning the name of the file, it now starts crashing, right? Well, it turns out that the reason why it's doing this is because when we are creating our folder, even though this is expressly saying that we want to create a query that is using T element, we are creating a query that is using folder items, because that's what folder does. Remember, if you go into folder up here, you can clearly see that folder is a folder of type file system info. There is, however, a generic folder, right? And so that generic folder is what you need to use here. So in here, you would then put T element, and you should be all set. And I'm gonna just return this back to throwing an exception because it's not necessarily needed for this example. But essentially, your non-generic type you can create here. Your generic types you create here. So now that I have a folder of T element, I'm able to convert that into an iQueryable of T element, which I could not do before. Because if T element was string, then folder by itself would not work. So look at that. We're back to being in here. And this time, when I return this, I now have strings, and it's just a name. And that is what's being presented. And of course, this continues in that I can actually do length. And that should still go through, and now what is returning is the length of the file names in that folder. The last thing that we talked about was being able to create this sort of like where clause, right? So for example, going here, where file extension is equal to that PNG. Okay. So this would be functionally the same as this without the two lower. Okay, so to get this going, we're gonna have to go back to our visitor, and this time we have to do the same kind of thing, but this time we are doing it inside of the where clause. So the first thing we want to do is we want to execute the constant as well here, because ultimately all that's doing is it's essentially just populating this list, right? That's all it's really doing, nothing else special, right? But once that's done, we now need to get this lambda as well and compile it. And in this case, I'm going to rename it to a predicate. And then the final step is that we are going to actually go in here and kind of do this, essentially do the same thing. But instead of doing that, we're going to do a where, and I'm going to have to change this into a bool. So we change it into a bool because dynamic invoke essentially returns an object, a nullable object. So just converting it to a bool and ensures that that it can be used as part of a where clause, because the where clause expects that. Okay, so this essentially should allow us to get the results that we want. And there we have it, 77777. Okay. And so why is it showing 77777? Because both select and this have been executed, and we can validate that here. That's a select, that's the where, both are executed. That's why you're getting this result here, because again, remember it's a name.length, but I don't have to do that. I can just use the regular name, and if I run this, just uncomment these, then you end up with just the PNGs. Hey, thanks for tuning in. Stay tuned next week. We have a big week. We'll be on site at Microsoft Ignite, interviewing MVPs, interviewing RDs, checking out new technologies, and reporting all that to you. Stay tuned.